So the 2017 coordinate geometry of the line question. ABC is a triangle where the coordinates of A and C are 0, 6 and 4, 2 respectively. G is the centroid of the triangle. Now, the centroid is the point of intersection of the medians. Now, just to explain to you what a median is. A median is the line that joins the midpoint of a side to its opposite vertex. Okay, so that's the midpoint of this side, and it's joined to its opposite vertex, so like that, and then the midpoint to its opposite vertex. So they should all go through the same point. So AG, so the line from A to G, intersects BC at the point P, so therefore that's P. And the ratio of AG is to GP is 2:1. So basically this line here is 2 parts and this line is 1 part. So this point is 2/3 of the way along. So 2/3, so to go from A to G, you've gone 2/3, but that's twice the distance as G is to P. So therefore you'll go another half of that, which is 1/3, so that takes you to 1. And likewise, you've gone from 6 to 4/3. So you've gone down 4 and 2/3. So you go down another 4 and 2/3. So you've gone from 6 to 4/3. So the distance there, is so to go from 6 to 4/3, you've gone down 14/3. So half of that then is another minus 7/3. So take away 7/3 from that. So 4/3, take away 7/3, and that will give you -1. So that's the coordinates of P. Just a translation. Now find the coordinates of B. Now, because P is the midpoint here, whatever distance we've gone from C to P, the distance from C to P is the same as the distance from P to B. And it's basically a translation. So we have the coordinates of C, that's 4, 2. So if P is halfway in the middle of it and P is the point 1 minus 1, then what have we done to go from 4 to 1? We've subtracted 3, so subtract another 3 to get from here to here. What have we done to go from 2 to -1? We've subtracted 3, so subtract another 3 there. And that gives me the point B. Now prove that C is the orthocentre of the triangle ABC. Now remember what the orthocentre is? It's the point where the altitudes meet. An altitude is a line that goes through a vertex and meets the other one at a right angle. So if C is the vertex, then this meets that side at a right angle, and this meets that side at a right angle. So I basically have to show that the slope of AC multiplied by the slope of BC equals -1 if C is the orthocentre. So that would be the proof of that. So get the slope of AC. So slope of AC, so 0, 6 to 4, 2. So y2 minus y1 over x2 minus x1. So that gives me -3/2. And the slope of BC, so B is the point -2 -4, and C is the point 4, 2. So y2 minus y1 over x2 minus x1. And so I've made a mistake somewhere here, have I? So C is the point 4, 2. So y2 minus that over x2. So what am I getting there? I'm getting, so I've got a mistake there. So go back to here. So y2 minus y1. Oh, so that's minus 4. Sorry, that's minus 4 there, yeah. y2 minus y1, that's minus 4. And then x2 minus x1. So that's actually 4 over 4. That's what happens when you take shortcuts, kids. So you get minus 1 there, and you get 1 there. And if you multiply the two of those together, you get minus 1. Therefore, C is the orthocentre. So sorry about that little mistake there.